Alrighty, Unit 2 Study Guide, Problem 1. State the x-intercepts of the given parabola, then sketch the graph, write the parabola in standard form, and state the vertex. So we got our function here, y equals negative 2x squared plus 4x plus 6. Anytime you're dealing with a function that you want to factor, it is always a great idea to factor out the greatest common factor of all your terms whenever possible. So we can look at that and see that we can pull a negative 2 out of all those terms. And what are we left with? Well, we're left with x squared minus 2x minus 3. We can check. Negative 2 times x squared gives me negative 2x squared. Negative 2 times negative 2x gives me positive 4x. And a negative 2 times negative 3 gives me a positive 6. So that's cool. I'm off to the good start. A good start. The good start, maybe. But I want to factor this. So let's just go ahead and do it. Leave that negative 2. I want to write this as two linear factors. So I'll throw my x's down. What are two numbers that multiply to give me negative 3 and add to give me negative 2? Well, I can go with negative 3 and positive 1. I can check myself. Negative 3 times 1 does in fact give me negative 3. Negative 3 plus 1 does in fact give me negative 2. So I'm good. I can take those linear factors and say that my zeros are going to occur when x is 3 and negative 1. So that's cool. I'm going to hold off on sketching my graph right now because I want to figure out what my vertex is to start. So to do that, I'm going to write it in standard form, which, to remind ourselves, is y equals a times x minus h squared plus k, where h is the x value of my vertex and k is the y value of my vertex. So in writing it in standard form, I will get my vertex, which will make it easier to graph. So let's go ahead and do it to it. To write it in standard form, what you got to do is complete the square. So let's go back to the equation we have written here. Negative 2. I'm going to keep that negative 2 factored out because even when you're completing the square, your best bet is to do it when you have a leading coefficient of 1 on your x term. So keep that negative 2 factored out. I have x squared minus 2x minus 3. I want to complete the square on that. So what I have to do is look at my x term. I want to take half of the coefficient on my x term. So negative 2 over 2. I want to square it, which is going to give me negative 2 over 2 is 1. Well, negative 1 really. Negative 1 squared is 1. So all I do is I rewrite it. Negative 2 minus 2x plus 1 minus 1 minus 3. And let's go ahead and pull all this extra stuff out because I kind of want to get it by itself like that. So to do that, I got to pull this minus 1 minus 3 out, which yes is minus 4. But be careful, that minus 4 is actually being multiplied by that negative 2. So it's not really a negative 4, it's a negative 4 times negative 2, which is a positive 8. So if we pull that sucker out, we're left with x squared minus 2x plus 1 plus 8. Cool. Now we can go ahead and factor that quadratic. It will be a perfect square now, which is awesome because that was our goal. So we got negative 2, x, what's it going to be? What's it going to be? Minus 1 squared plus 8. So that's sweet because that tells us our vertex is at negative, my bad, our vertex is at positive 1, positive 8. And let's just remind ourselves, scroll back up, our zeros are at 3 and negative 1. So now we can go ahead and graph it, which is cool. Also, let's go ahead and look back at the original equation. We look at our leading coefficient, which means the coefficient on our highest degree x term. So in this case, negative 2. -2, that is going to be a transformation that reflects our graph. It flips it vertically, so we know we're dealing with something that looks like that. All we got to do is fill in the details. So I'm going to go through, I'm going to mark my zeros. So 1, 2, 3, -1. And I'm going to go ahead and mark them like I said. So I'm going to go to 3, and I'm going to go to -1. Let's go ahead and mark my vertex now. That's at the point 1, 8. So I'm going to go 1, 2, 3, 4. I'm going to say I'm going up by 2's on there just to make it work a little bit better. My vertex is at 1, 8, and I draw it in. And I'm done. So I found the equation of the parabola. I wrote the equation in standard form right there. And let's see, I found the x-intercepts. Well, really, I told you where the zeros were. So if I wanted to find the x-intercepts, I'm going to have to say that the x-intercepts are the coordinates -1, 0, and 3, 0. Because if it says x-intercepts, really you should be giving a coordinate pair there. So I got the x-intercepts, I sketched my graph, and I wrote the parabola in standard form and identified the vertex. So I'm done. Yay. Good for us.